So I think you probably have never done sequences, series. That's not something that comes up in Algebra 1, not something that comes up in geometry. Don't let that scare you. This is something new that I need to show you. So I'm going to talk about how to get the terms on a sequence. Recursively defined sequence is just a special type of one. And then the sums. Sums mean you're just adding up some terms together today. There will be some fractions. Don't freak on me on the fractions. You can use your calculator for the fraction.
Are you putting the video in Google Classroom?
Yes.
Okay.
All right, so sequence, of course, infinite list of numbers. And these numbers will have some sort of pattern. Now, depending on the pattern, okay, depending on what the pattern is, you might be subtracting the same thing. Easy. You might have squaring. You might have fractions. It has all sorts of different operations. Now, there are some specific types of sequences, arithmetic and geometric. When we get to those, I will give you a very lovely little formula sheet to use on those, just for the record. So the dots, of course, mean that the terms go on forever. Notice the first term in this sequence is 5. They call it A1, A2 is the second term, so on and so forth. Excuse me. Now, normally assume that the first term is always A1. Once in a blue moon, you will see, they'll put a little fancy note there, assume n begins with 0. So that might be A0, A1, A2. But always assume you start with 1, because you're going to see that's important here, unless they give you some sort of different note of a different starting number. Otherwise 1. So find the first 5 terms. Okay, I got it in the 100th term. Piece of cake. No crazy note about starting with anything but 1, so we're starting with 1. So I want A2, where are we going, to 5? Okay, A5. And they want A100. Okay, why not? Now, most of this probably you can do with a little mental math. I'm going to show you the setup, and then we'll get it and be done with this. To find A1, are you ready? Ready? You replace n with 1. So you get what? And then you replace n with 2. And then you replace n with 3.
This is lit. I'm not.
Now, I'll be honest. From this, I don't write out the computation. I don't expect you to write out the computation. This chapter is about patterns. What's the pattern?
I'll buy 2.
So 7, 9, right? Why are we going to write work? Now, we probably should put the 100 in. I don't want to count out plus, 2 up to 100th term. So I'm just going to do 2 times 100 minus 1. So what's your 100th term? 199. This is what we're doing today. And while it gets fancy, they're going to have you add up some of the terms then. Okay, let's do a course. Here we go. They want the first 5. I know. All right, let's mental math it. What's 1 squared minus 1? 2 squared minus 1. 3. 3 squared minus 1. What's your third term? Third term. What's your fourth term?
15.
And then your last, your fifth term.
24.
So unfortunately on this one, there was no consistent pattern between the terms, like over here where you were adding 2. So you do have to plug in the value for n each time. And then they want that crazy 100th term. What's 100 squared? Oh, you might need a calculator for that.
It's like 999,999. Is it?
It's a big number. What do you got?
Is that not what I just said?
So it's pretty much, I think it's what Avery was saying. 100 squared minus 1.
Oh, wait, no. I was up too much.
Yeah, that's what I said, Avery. Yeah, that's what I said. You said 99,000.
I just heard a lot of 9s
You're
happening.
bad, kid. You're cognitive math skills, kid. You're bad.
Oh boy, 99. That's a 9. That's a flat 9. Now, other things too. When you write these out, clearly, I don't expect to see that you did, 1 squared minus 1. You don't have to write that out. Also, sometimes I have kids that will just write them as kind of in a row, like this. I don't care.
I'm going to do that.
If you like it that way, just takes up a little less space. Doesn't matter to me. As long as you got the right numbers, my friends. Okay, well, let's do a fraction. So I'm going to do these in a row just for the sake of time. So I'm going to put 1 in for both ends. So first term is going to be 1 over 2. Now put 2 in for both ends. So what's your second term? 2 over 3, 2 plus 1. Third term, 3 over
3. 4. Right.
fourth term, 4 over,
5.
and the fifth term, 5 over.
6.
So you can just list them like that. Now don't forget they still want that 100th term. So I'm going to have, this one I'm going to write out. I got 100 over 101.
What's the point?
Yeah. All right, let's do one more, some crazy fractions here. So first term, let's write it out. You're making me nervous. So what's your first term when you simplify that? Negative 1 over
1.
2. So there's our first term. What's negative 1 squared over 2 to the second? Let's simplify that.
Small number.
1 over,
Guys.
I'm getting worried here. Thank you. Negative 1 cubed over 2 to the third. What's negative 1 cubed?
Negative 1 over 8.
Got it. Okay, negative 1 to the fourth over 2 to the fourth. Well, what's
Is that
negative
like
1 to the
32?
fourth? Yeah.
Okay.
2 to the fourth, 16. 2 to the fifth is 32. So what's your last term? Just give it to me. Negative.
Negative 1 over.
All right, so before we do the 100th term, which I'm going to do here in a minute, okay, I want to point out one key detail to you. Notice the terms are alternating in sign between positive and negative. I knew that was going to happen before I even started calculating. What is specific about the formula that makes that happen? What made it switch sides?
The negative.
The negative 1 to the power. So eventually, we're going to go backwards. I'm going to give you the terms. You have to write the formula.
Whoa.
Everybody's excited about that, I hear. So just recognize this part will result in the sign change. When we get to it. All right, they want the 100th term, so let's do that. So negative 1 to the 100th over 2 to the 100th.
It's a positive 1.
So positive 1, 100 negatives positive. Type in 2 to the 100th.
Big number.
Is it like.
Maybe you're not gonna get it.
I don't know if you could do that one in your head, but I appreciate trying.
That's what I was gonna guess.
Now, what does the E mean?
Power 10.
Power of 10. So that's 1.26 whatever times 10 to the 30th. Or, wait for it. That means you would move the decimal places 30 times to the,
Right.
I don't know. I'm not.
so,
This way.
isn't that a really giant number?
That's an exercise right there.
So let's make our lives easy because that's going to be such a ridiculous fraction. I'm just going to leave it 2 to the 100th power
Facts.
because that's going to be crazy. All right.
Fraction like fraction.
Now, just like I warned you, quiet and listening, too much chatter, people. Just like I kind of warned you, now we're going backwards. I'm giving you the terms, you're writing the formula. These are pretty fun.
What? This just sounds so.
So find the formula is what they're really asking you. Clearly it's going to have a fraction. Now here's my advice. When we get to specific types of sequences, there are formulas to use. Not the case today.
This one you just add.
You just have to pull it out of your you-know-what.
Add 2 to the top and 2 to the bottom.
Okay, so I'm worried about that. Alex.
Think you can grab the homework when you want?
We're
No.
leaving second.
Are you
Oh,
kidding me?
yeah, you are. For volleyball,
Yeah.
right? What time do you leave?
Like 5 minutes.
Okay. Yeah, that's fine.
No,
Yeah.
like right now.
Yeah. All right, have a seat, please. Now, hold on. Do not write this because I might end up erasing. This is kind of a trial and error. So I heard, of course, adding 2 to the top. Now, wait a minute. Remember, to put the first term, you'd put a 1 in there. What's 1 plus 2?
Oh, just kidding.
Not 1, right? Not 1. Okay, so not it. So here's my pro tip advice. Let's do the numerator last. I'm going to start with the bottom because I think those are easier. What do you notice about the denominator, any
N
pattern?
plus
times 2.
So I heard n plus 2, I heard times 2.
I don't know, I got times. I didn't need the times.
What's 2 times 1? 2 times 2. 2 times 3.
Dang it.
2 times 4. Agree with that. Alright, we gotta figure out the top. You are right, there is a 2 involved with it. I'll start you with it. I'll give you a hint. There's more. There's more.
Plus 1. Minus 1.
Minus 1. Minus 1.
How did we just find that out?
So again, if you put 1 in here, 2 times 1 is 1. 2 times 2 is 4 minus 1. 2 times 3 is 6 minus 1. So this is the worst part of this whole chapter, if you ask me, because I can't just say, hey, do this, this, this. You have to look at it and magically figure it out. Like this one. Now, I will tell you this. I don't think this is going to be as bad. You have the alternating signs.
That's what you have?
So remember, we talked about the alternating signs. So I'm going to start with the -1 to the end. That will switch the signs. That only does the sign switch. What else do you need? Or what else do you notice about those numbers? Don't worry about the signs, just the 2, the 4, the 8.
They get bigger.
They get bigger.
Double.
Wow.
They're multiples of 2. Double.
Multiples of 2, so 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth. They're multiples of 2. 2 to the power.
What?
Whoa, wait, I don't like that. Can we do so?
I'm going to get dramatic and put a dot.
So
That helps you. Okay, I'm ready, Riley. What do you got for me?
So in parentheses, -2 to the power of n.
Say that again, -2.
To the power of n.
I would take that. I would take that.
Okay,
Yes.
that's what it is.
Yeah, I was confused with the first one. I was like, what is going on there?
Same thing, same thing. So just if you need the sign
Oh,
change,
I got you. I see.
I'm running both.
they both work.
Yeah.
Now, which makes this chapter really fun for me to grade, because sometimes, focus people, there are other versions of the formula that work. Clearly both work on this case. I would take either happily. That's to me the worst part of it. Okay. All right, flip the page. Flip the page, my friends. So, let's talk about recursively. People, pull it together, please. This should be going a lot quicker. Recursively defined sequences. Now, it sounds fancy, but all that is, it says some sequences do not have simple defining formulas. The nth term depends on some of the preceding terms, basically, is what is happening. We call this a recursive definition. Now, so that means instead of me just plugging in 1, 2, 3, 4, you are using the previous term or terms, depending on the problem, to get the others. So I'm actually going to do these recursive ones a little out of order. If you ask me, this is a little tougher than like example 4. I'm going to start with example 4. I will come back to 3, but I'm going to start with example 4. Find the first 5 terms of the sequence. Notice they gave you the first term as 15. Okay. I'm going to just keep going here, set it up. 4 and 5. So notice there is no place for me to plug in a 1. There's no K in that, just a normal K, so on and so forth. So we've got to look at this. Good luck, guys.
Thank you. I know you all miss me.
Oh, Lord.
See you all Monday.
And we have to
Albert
look.
out.
Oh, Lord. We have to look at the subscripts, the K and the K minus 1. So that's what I'm really kind of zeroed in on. And this is going to be key when we get into what's called mathematical induction in the coming up section. Don't worry about it yet. Now, first question, easy question. Which expression is greater, K or K minus 1? Okay, so all this crazy formula is telling you is to get your next term, because the K is more, to get your next term, it's the last term plus 3. Okay, I got it. So to get this one, it's the last term plus 3. To get this one, it's the last term plus 3. I mean, I know you guys can add it. I'm just writing it up. Last term, which was 21, plus 3. Last term, plus 3. So you just, I mean, the math is easy. We can all add 3. I mean, goodness. But you have to be able to kind of decipher that notation. So it's just saying, hey, to get the next term, add 3. You got it. Now, I haven't forgotten about example 3. I'm going to come back to that, but again, I'm going to do the easier ones first. So let's do this one. It looks crazy, but I promise it's easy. Fibonacci sequence defined recursively. Okay, write the first 6 terms and just a little blurb over there about where the Fibonacci sequence comes from. Okay, now notice here's one where they're starting at A0. Okay, fine, whatever. And then they give you A1. Now we want the first 6 terms, so I need A2, A3, A4, and A5. That will be 6 total. Notice we're starting at 0. That's why you're stopping at 5 and not 6 this time. Now again, it's the crazy notation you have to decipher. You've got 3 subscripts on this one. Out of the 3, okay, k minus 2, k minus 1. Which is the largest? K. So this is saying, hey, to get the next term, it's the 2 terms back, k minus 2, 2 terms back, plus the previous term. Well, in our case, 2 terms back, it's going to be the 1 plus the last term. To get this one, 2 terms back, 1 plus the previous term. To get the next one, 2 terms back, so 2 plus 3 plus the previous. And of course our last one, 2 terms back, 3 plus the previous. So the math is super easy if you can decipher those crazy subscripts, okay? And like I said, you're going to see some of that coming up in another section. So let me go back and do 3 now. I went too far. Okay, find the first 5 terms of the sequence. All right, let's do it. So clearly you're starting at A1. And I'm going to show you something on your graphing calculator for this one. What do you need? 5. Okay. So of course, taking a look here, n we know is higher, n minus 1, previous term. So to get the next one, we're going to have our 3 times the last term, which was 1, plus 2. All right, I'm going to mental math at 3 times 3. Got it. To get the next term, we've got the 3 in the front. Previous term, which was 9, plus 2. So now I'm really doing 3 times 11. So this is kind of growing pretty quick on us. That's okay. To get our 4th term, still the 3 times our last term, plus 2. You might need a calculator for that. 3 times 35. What do you got for 3 times 35? 105. And then, of course, 3. Gonna need a calculator for this. 105 plus 2. I did that earlier. I forgot what it was. 321. You got it. Okay. How am I doing the 20th term? Because don't I need the 19th term?
We probably put it in our calculator somehow.
I don't want to write out 19 terms, and I'm pretty sure you don't either. So here's where we're going to have our graphing calculators do some work for us.
Let's go.
All right, so pull up your calculator. You have not done this before. Let me show you. Let me clean this up. So in your mode, and I'm going to pull up the mode button here. If you take a look, normally 98% of the time we work in this function mode. We've talked about parametric and polar equations in here. There is a sequence mode. So I'm going to go down and put my mode on sequence here. Come on, calculator. One more. Come on. Hit enter. So put your mode on sequence, and I'm going to quit out of this. Because I don't want to keep generating all the terms because I would need the 19th. So now when you hit your y equals menu, it's going to look a little different. How do you like that? Okay, so this, I'm assuming, is already defaulted to 1. It usually is. Double check that, okay? And we're going to put in our formula here. So to put in the formula, meaning I'm going to show you how to type that into the calculator, okay? Let me get my calculator back out. So you've got the 3, like we had the 3, obviously. Throw in a parenthesis. Now, here's where it gets a little dicey. Because remember, it was 3 times the previous term. Watch this. So you're going to put in, you got to find u, which is above 7. And notice, mine might be a different color than yours. Mine's that light blue color. So I'm going to have to hit alpha and then 7. Maybe. Alpha. That might help if I hit it here. I need taller shoes on alpha. Where's my U here? Alpha. Second. Yeah, sorry. I got too many. Mine on my own calculator are different colors, so it always throws me off. All right, close that up. Parenthesis. So that's saying your sequence, and now I need that little subscript, the n minus 1. So now if you hit your x, comma, t, comma, theta, comma, n button, it switches it to the n. Normally it's default to us for x when we're in function mode. Put your minus 1, of course. And then we've got r plus 2. That was a whole lot of typing. So kind of goofy to get that subscript, the n minus 1 for us, and that now, but don't hit table yet, because we have to tell it, I got a down arrow here, what's U1? What's the first term? You have to put that in. They gave you the first term, we started at 1. Okay. If you don't put that in, it's going to get angry at you and give you like a syntax error message. So now I'm going to pull up the table. I'm going to scroll up to where we started at 1. And oh, look at, we got 1, 9, 33. We had the 321. We had all those values, right? Now, we want the 20th term. I got a down arrow here a ways to get to 20, which is making me nervous. These are getting big. Okay, so 4.65 E9. I'm not writing E. What's the E mean? Times 10. So I'm going to put 4.65 times 10 to the 9th. Or, for the love of math, if I want that a little more exact, because unfortunately you just have so much width, there's so much room on that column for the numbers, I'm going to quit out of this. If I actually type in U of 20, so I'm going to do second 7, I'm going to actually pull up the right U here of 20. It will give me a little bit more exact number because I was limited on space in that stupid table in there. Do I care which one you give me? No, I don't care. But again, just to show you. So I'm going to write that one down too, which I forgot all the numbers. Look here. So that's how you can get some of the numbers off your table, of course, if you need U like to the 20th. Now, of course, you know, when you're done with this or you're using your calculator in chemistry or some other class, make sure you go back into mode and put it back on function. So you're back in your normal y equals style menu, okay? Just for the record. All right, we're on the home stretch, my friends. So we did all the recursive stuff. We got some easy stuff to finish it off here. We have to talk about sums. Well, just like the word says, you're going to add the terms, okay? So in calculus, we do a lot of sums of the terms. S1, of course, sum of the first term. S2, sum of the first 2 terms. S5, sum of the first 5 terms. You get the gist. And they sometimes call those like the third partial sum, fourth partial sum, whatever the case may be. So find the first 4 partial sums and the nth partial sum, so wording of all of those. So first thing I would do, let's get some of the terms written out just like we did earlier, and then I'm going to worry about the adding. So let's do A1. 1 over 2 to the first, or a half. Let's list A2. 2 squared, so 1/4. You get the gist. A3. 2 cubed, 8. 2 to the 4th would be 16, of course. So just writing out the terms, nothing fancy, we've done that. Now, this is still easy. So it wants the first 4 partial sums. Okay, first 4 partial sums, we can do that. So we want the sum of the first term. I mean, what's the first term? That's all it is, okay? Now, first 4, so it wants the sum of the first 2 terms. All right, so you got to figure out what's a half plus a fourth. 3/4. You can use your calculator if you're not great with fractions. No judgment, little judgment. Now it wants the first 3 terms. So a half plus a fourth plus an eighth. And then, of course, it wants fourth, wants us to end at 4. So a half plus a, you got it.
Yeah.
And you're probably doing this all on your calculator. I'm just writing it out for
I
you.
did it in my head.
Did you?
I did.
Nice. All right. And of course, we keep going if you need the fifth partial sum, so on and so forth. That's as wild as the sum gets. Now, sometimes, maybe you've seen this Greek letter before, sigma. All that means it looks fancy. This is what we just did. You're finding the sum. It's just another way to represent, do the sum. So you can write the sum of the first terms. It's called summation notation, or of course sigma notation, because it's the Greek letter sigma. Now, a couple things to point out to you. So you're going to have, it's kind of blurry here on our picture, you're going to have this bottom number underneath the sigma. That's your lower limit. So that's telling you what to start with. Again, most of the time we start with 1. Once in a blue moon, you saw we started with 0 today. The top number is telling you how many terms I want you to do the sum of. So just like on the last problem, we did the fourth partial sum, there would be a 4 up there. So it's just another way to represent, hey, I need you to add up these terms, okay? So, easy enough. I'm going to start with 1, and we're going to end at what? What's your upper limit? What close?
Oh, I'm just kidding. I'm blind.
5, that's a 5. Okay, so first I'm going to put 1 in for k. I know you know what 1 squared is. I'm just writing them out for dramatic effect. I'm going to put in 2 for k, 3 for k, 4 for k, and 5. So no different than we were writing out the terms, but now you get fancy and you add all of these together. That's what the sigma notation means. Now they just want you to add. So you can do that in your calculator. Maybe we can mental math it. 1 plus 4 plus 9 plus 16 plus 25. And you get 55. Yeah. So the sigma just means now add the terms. Riveting stuff, I'm aware. All right, let's do the next one here. So a little fraction, but notice, don't cringe at the fractions. It's not that bad because you're starting at what? 3, and we only have to go up to 5. That's not that many. So I'm going to put a 3 in for j, 4 in for j, 5 in for j. I'm going to stop there and we're going to add them. Can you do that in your head?
Wait. 5,
What's your common denominator?
60.
60.
50. Wait, what's that? Oh, 8. 15, 32, 32 plus 16. I mean 15. 32 plus 16. 15.
Which is 47.
47.
You got it. All right, last one of these guys. Okay, so we're starting with 1 and we're ending at what? Okay, weird. If I put 1 in, you get 2. There's no variable. If you put 2 in, you get 2. A lot of 2s here. What am I at? 4, 5, 6, right? 4, 12. So this is just what we call a constant sequence where all the terms are the same. They're always 2. All right, last thing we got to do today, easy. So it says, well, the hardest part is I'm not great at writing the sigma. Okay, writing sums in sigma notation. So they want you to write it out.
Oh, man.
Could be better, could be worse, could be better. Okay. So first let's find the pattern of the numbers. What are they doing to the numbers? It's pretty obvious. They're raising all of them to what power? 3. Now you pick your variable. N, J, K, I. We've seen it all. I'm going to do N to the 3rd power. We're clearly starting with a 1, and you're ending at what number? 7 is your upper limit. So 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5, 6, 7 cubed. Add them up. That's what we got. I love this stuff. Well, except I can't draw the sigma. All right, final one.
Compared to that one.
Okay, don't overthink it. What are you doing to the numbers? What's our operation? Square rooting it. I'm going to use n. You can use whatever variable you want. You're starting at 3, so that's our lower limit, and we're ending at 77. Glad I don't have to add those together. Got it. That's as wild as the first section gets. Just be conscientious if you have your mode still in sequence. You might want to put it back to function right now so it doesn't mess up anything in your geometry class or your